1, 2, let it be 3. How the force of interaction between 1, 2, F21, F23. Similarly, F12, F13. What about on 3? On 3, it will be F32 will be like this. F31 in this direction. I think possible equilibrium, you see. If these two forces are equal, this will be in equilibrium. If these two forces are equal, this will be in equilibrium. If these two forces are equal, this will be in equilibrium. Yes, the total system can be in equilibrium. So let this be at a distance x. Let that be at a distance x here. Then for equilibrium or at equilibrium. At equilibrium, F12 equal to F13. What is F12? F12 should be equal to K phi q 2q by L square. F13 equal to K whole square. So therefore this will become 2q. Is asking even the q also. We don't know that q also. The equation after solving, okay, will end up this much. Call this equation 1. Similarly, let me look at the point charge 3. The net force on it should be 0. The net force on it should be 0. So F31 should be equal to F32. So what is F31? F31 should be equal to K phi q L minus x whole square. What about F32? Should be equal to K q 2q x square. Already the sign we have taken care. No need to write minus q. Already the sign you are indicated by assuming the direction of forces. Only magnitude of forces you have to equate here. So this should be q will get cancelled. I think just wait. Yeah, this will be. So we'll end up the relation between here phi x square equal to 2L minus x whole square. Phi x square should be equal to, so this will become x square equal to 2 by 5 under root L minus x. X is equal to, or either way we can write it. Root 5 by 2 will write it. So this will become root 5 by 2 x equal to L minus x. So this should become root 5 by 2 plus 1 x equal to L. So what is the value of x equal to L into root 2 by root 5 plus root 2. This should be the value of x. And where do it will be? It will be between the point charges. Now I'll substitute this value of x here. Here I'll get expression for q. So this will become 2q L square equal to q L minus L root 2 by root 5 plus root 2. Solve this. So this will become 2q is equal to q by root 5 so what should be the magnitude of this? 2 root 5 by root 5 plus root 2. This should be the magnitude. Okay, these are the answers, sir. The position between the point charges, and this should be the magnitude, and this should be a negative charge. Okay, the question comes like, sir, what made you to assume negative charge? Why don't you keep it here? Why you took suddenly? Means we should think by chance. Okay, no, see, you have to analyze here. There's nothing wrong. So what is the analysis you have to do is, so why you are making us to think like this only? Why not any other method? Means if a student thinks in this way, okay, let me take, this is 2q. These are the charges, no? Let me bring a third point charge somewhere here. I'll keep the same negative charge. What's wrong, student? Okay, will you get answer for this? Okay, let's see the forces acting here now. F23, F21, F12, F13, F32. Possible, equilibrium possible? Not at all, no? Maybe this can be an equilibrium. What about these two? Can never be an equilibrium. So equilibrium not possible. A student has to analyze. He has to analyze. It's not that something directly you have to think in that way. You can analyze. So let me do one thing, sir. Let's do positive charge. I'll keep the positive charge in between. Again, okay, this will be 1, 2, 3. F12, F21. There's a force of interaction. F32, F31, F23, F13. Oh, already negative charge. No, sorry, it should be positive charge. Already we discussed, no, negative. I'll change it. I'll change it. Huh? All are positive, no? So therefore, F21, F23 will act here. F12 and F13. Okay, maybe on this F32 and F21. This can be an equilibrium. The middle point charge can be an equilibrium. What about these two? Not possible. They cannot be an equilibrium. So this also ruled out. Equilibrium not possible. So like this, these are the ways a student has to fight with the problem. Huh? Nothing wrong in assuming whatever that one. Analyze and conclude it. Okay, the last situation, if point charge Q is kept outside external to the point charges, phi Q, 2Q. Let me keep it here. What about in this case? Will there be any possibility of equilibrium? 1, 2, 3. Then what are the forces like a F12, F13, F23, F21, F31, F32. I think not possible, no? Point charge 2 can be in equilibrium, but what about this? Equilibrium not possible. So again, what is the conclusion you can make it? This is also not possible. So what is finally what is left over? The assumption what I made. Got the idea, no? A student has to really analyze it. It's not that suddenly I'll think in this way. So what made you to keep point charge at the midpoint of, what made you to keep the negative point charge at the in between these two positive point charges? No, not what made. I have a background. I'll keep negative point charge here. Equilibrium not possible. Positive point charge in between not possible. Positive point charge external to the somewhere here. Then also equilibrium not possible. Then only alternative left over is what? Negative point charge. Let me keep it here. S. Now the net force can be 0 on all 3 particles. Equilibrium is possible. Then I discussed. I got the answer. Analysis we have to do here. It's not something like I will make